Okay, so this is the key to the first quiz. And in number one, you want to express the following in roster notation. And so you're given the set builder notation, and you're told that you have the set of x's, such that x is an element of the natural numbers. So you're told x is a natural number. And you're told that x must be greater than 7. All right, so the natural numbers that are greater than 7 are the ones you want to list. All right, notice there's no equal sign, so you cannot use 7. So you're going to say 8, 9, 10, and remember there's an infinite number of natural numbers greater than 7. So you can't list them all, so I'm just going to list one more, and then you're going to do that ellipsis, just like this. All right, and you got to make sure you have your braces to represent a set, and this is your answer. So that's roster notation. Okay, number two, you want to determine if each of these statements is true or false. Okay, so here's your set, and so this set has these elements in it, 1, 2, 3, 4, and 5, and notice those are elements, and the question is the element 5, is 5 an element of this set? And the answer is yes, so that's a true statement. And then over here, you're given this set, and if you were to list this, you would have 2, 4, 6, 8, 10, and so on. So those are even numbers from 2 to 18. And notice that 7 is not one of these, so that's false. Number 12, part C, you're told 12 is not an element of this set, and that's true. That's a true statement. 12 is not an element of this set, so that's true. Okay, in letter D, you're told that 6, true or false, is 6 an element of this set. All right, so what we have here is this. So it's a good idea sometimes to write this in roster notation. So we have this set that is made up of natural numbers less than 10. That's what this says, less than 10. So we have 1, 2, 3, 4, so on, up to 9. Okay, up to 9. Not 10, because there's no equal sign here. So the question is 6 an element in here? And the answer is yes. So that's a true statement. Okay, this one, same idea. You're asked, is 8 an element of this set? All right, well, so we have the set builder notation, so you're told that x is a natural number and that x must be between 2 and 8. Notice that there's no equal sign at 2, but there is an equal sign at 8. So what that means is this. The next natural number above 2 is 3, so you're going to say 3, 4, 5, 6, 7, 8. And so is 8 an element of this? The answer is yes. That's a true statement. Okay, now be careful with this one because notice that this has a brace, or it's inside of a set. So that's asking, is this set an element of this set? Okay, so is this set an element of this set? So that's where it gets a little confusing for some of you. So remember, this set is a subset of this set. Okay, but if I'm asking, is this an element, then this would be a true statement. That would be true. See, this is a true statement because 4 is an element and I see it here. But this is a set. I don't see this set as an element. If I were to see the set as an element, this is what it would look like. So if you had this, let's say, it would look like this, 4, 5, and then a set with 4 in it, like that. Then that would be a true statement. See, you see it here. You see it. You see this thing right here. Okay, so that would be a true statement. So this is false. Okay, now here you want to find the cardinal number. So remember, the cardinal number is the number of distinct elements in the set. So in part A, you can just count these, and they're all distinct. So that's 1, 2, 3, 4, 5, 6. So the cardinal number for this set is 6. what you may want to do for part B is actually list this in roster notation just like this was. And so you're told that this set right here is consists of natural numbers, and they are between 4 and 10, including 4, not including 10. So we have 4, 5, 6, 7, 8, and 9. And so when I count these, that's 1, 2, 3, 4, 5, 6. That's 6. All right, over here, now you got to be careful with this one because of what you're told. You're told that x is a number less than 3, and at the same time, it's greater than 8. All right, so that's what you have. So you have these numbers that are less than 3, and at the same time, it's greater than 8. Well, there's no number that's less than 3 and greater than 8, so that's the empty set. So that's an empty set. And so now I'm going to ask you, how many elements are in this empty set where there aren't any? There aren't any elements in this empty set. So the question is, how many? Remember the cardinal numbers, how many elements there are? Well, there are no elements, so you're going to say 0. Okay, now make sure you're using the number or the symbol for 0. Don't use this. Some students use this for 0, but remember, we're dealing with set here, so don't confuse yourself. This means empty set, this means 0, so don't use this. That's the symbol for empty set. All right, so that's number 3. Okay, number 4, you're asked, number 4, you're told for each pair of sets, determine if they are equivalent, part A, or the equivalent, and then part B, are they equal? So just write yes or no. So remember, equivalent sets have the same cardinal number. So if you look at set A, there are 4 elements, so the cardinal number is 4. And then in set B, the cardinal number is also 4. So basically we have this. Remember, the symbol for cardinal numbers is this. So cardinal number for A is 4. The cardinal number for B is also 4. So yes, they are equivalent. So you're going to say yes here. In part B, they're asking, are they equal? Now remember, equal sets have to have the same elements. So no, they are not equal. All right, over here, the cardinal number for A is 1, 2, 3, 4, so that's 4. And the cardinal number for B, remember you list them once, so we have 2, 3, 4, and 5. So that's also 4. So the cardinal numbers are the same, so they are equivalent. But if you notice, set A has the same elements as set B. They're the same elements. All right, so they are equal. All right. Now, remember, finite sets are sets that you can actually count how many elements there are. Infinite sets, you cannot count them. They're an infinite number of them. You can't count them. So if it's not finite, it's infinite. So here I can count how many sets are here. 1, 2, 3, 4. How many elements are here? 1, 2, 3, 4, 5. So I can count them. So that's a finite set. Now over here, so you have 2, 4, 6, 8, 10, and then you have the ellipsis, which means it keeps on going. So you cannot count how many there are. So that's an infinite set. And then over here, you're told that x is a natural number, and you're told that x is between 5 and 12. So is this finite or infinite? Well, if you list the roster notation, so remember, there's you see there's no equal sign, so you can start with 6, 7, 8, 9, 10, and 11. And notice you can count how many there are. 1, 2, 3, 4, 5, 6. So that's a finite set. Okay, so that was quiz number 1.